What's up, everyone? Today we're going to talk about the cosine rule, so let's get into it. So the cosine rule is very similar to the sine rule in the sense that it can solve right and non-right triangles, the latter of which we're still going to be focusing on. The cosine rule is unique in the sense that it has kind of one formula that you can use to find a side, because if you notice for all of these sides are almost isolated. It also has a formula to solve for the angle. So if you notice in this problem, or in this formula, the angle is almost isolated. Now it's important to note that it's up to you to rework these formulas depending on what you're looking for, since they only give you the C information. But we're going to focus on that in our first couple of examples. So let's go ahead and just jump into example 1. So our first example says that side A is 16, side B is 10, and angle C is 110 degrees. And we're looking to find side C. So if I'm looking at what I'm given, the best or the most asked question once we do sine and cosine rules are, how do I know which one to use? Now, if you remember to the sine rule, you have to have connecting pieces in order to use it. So I would have to have angle B and side B, or angle A and side A, or my C information. And I don't have that here. I'm looking for the connecting piece to C, but I don't have information to find it using sine rule, and I also don't have angles A or B. So that's why I can't use sine rule. It's not that, there are particular rules that you have to follow to use whichever one. It's just sometimes you can't use one or the other. So in this case, I'll have to use the cosine rule. So if I'm trying to find side C, that means I'm going to be using the formula where the side is almost isolated, almost just because it has the square. In this case, luckily we are using or trying to find side C, so it works out that I can use this. But important to note, in case you weren't finding C, that if you notice whatever side you're looking for, that's the angle that you're taking the cosine of at the end. The other two sides just fall into place in the other pieces. So even though, if you're trying to find side A, we may not give you that formula, you can easily just rethink the C formula for what you need. But I'm going to copy this formula onto the next page so that I have it. All right, so here's my formula, and let me plug in what I know. I obviously don't know side C, that's what I'm looking for. I know side A is 16. I know side B is 10. And then I have A and B again, times the cosine of angle C, which has 110 degrees. So two different ways you can go about this, and bringing back in that concept of rounding prematurely again, that I can just go ahead and type this whole right-hand side into my calculator to get what that equals. But before I round, I might want to take the square root of that answer so that I don't round prematurely. If you're working in Desmos, or if you are just scared that you might round prematurely for whatever reason, you can always go ahead and square root it before you plug it into your calculator. Now you can just type in the square root of that whole side, and there's no reason to chunk it. A lot of people try to, do just cosine of 110 and then multiply. There's no reason to chunk it up. Just type it all in at one time and you're good to go. And when I do that, I get 3 sig figs, I get 21.6, and I don't have units here, so that's just it. That's my answer. All right, our next example, we're trying to find angle B down at the bottom, given that we have side A as 14, side B as 12, and side C as 7, all in centimeters. So this time we're looking for an angle. So that means looking back at the formula booklet, or what's given to us in the formula booklet, I'm going to want to use this formula instead of this one, just because they already did the work for you in this one, where they solved for the angle, or almost solved for it. The only downside is that this has angle C isolated, versus we're going to be looking for angle B. So if you notice in the formula, whatever angle you're taking the cosine of, that's the angle or the side that's being subtracted in the numerator. And then your other two sides fill in the other two spaces. So it's really just, again, figuring out what are you looking for in your problem and kind of subbing in the sides and angles for what you need from the formula. So I'm going to go back to our other side and just, reinterpret that formula a little bit. So we're looking for cosine of b. Should also point out that I can't use sine rule because I don't have any angles. So there's definitely no way to have a matching side and angle here. So that's why we have to use cosine. So with the cosine of the angle formula, again, whatever angle you're taking the cosine of, that's what's going to be subtracted at the end. That's the side that's going to be subtracted at the end. So side B, 12 squared, because in the numerator, they're all squared. That's what's going to be subtracted at the end. The other two sides squared don't really matter the order. I'm sure they would normally go in alphabetical order, but it doesn't matter because they're being added. So who cares? But I'm going to do a squared first and then my c squared, which is 7. So note that all three sides are represented in the numerator. In the denominator, you're taking those two sides that you just dropped in, a and c in this case, and you're just multiplying them by 2 in the denominator. So b, in this case, is the only side that's being used once, since that's the angle we're trying to find. And then same kind of deal as our previous example, that yes, you can just throw this in your calculator and then work from there. But again, to not round prematurely, what I'm going to do first is recognize that I'm finding a missing angle. So that means I'm going to have to use the inverse cosine here. So I'm going to write that out first, or if I was just jumping to my calculator, I could just type in the inverse cosine of that whole big fraction, and that's what I'm going to type into my calculator. All right, so this is what I'm typing into my calculator just to show you what it looks like in Desmos. Sure, again, you're in degrees, and rounding to 3 sig figs means I'm going up to 59.0. So just to kind of turn your wheels a little bit, if I was looking for angle A, so not asked for, but just kind of side note, if I was looking for the cosine of angle A, that means A would have to be the one subtracted in the numerator. So a squared is being subtracted. B and C would be added together on top with it and squared. And then in the denominator, again, it's 2 times the first two sides. So 2 times B times C. So just in case you did want to write it down somewhere, that's what the A formula would look like. All right, our application example, finding the length of the lake, C to B. So we're finding this distance over here. Given the distances, A to B is 290 meters, A to C is 225 meters, and angle A is 72 meters. So again, law of sines can't be used here, or the sine rule can't be used here because I don't have a connecting piece in order to use it. So that's why we're going to use cosine rule. So I'm looking for this distance from B to C, which I can also call side A since it's across from angle A. I'm looking for a side, so that means I'll want to use the formula that starts with the side I'm looking for squared. So you can either go to the formula booklet and see if you can interpret what the formula for this would look like, or you can go back a few slides and just copy it over. Right, so here's the formula I'm using, and let me plug in what I know. Side B is 225 squared. All right, so let me plug in what I know. I know side B is 225 squared. I know side C is 290 squared. I'm saying squared because it's squared in the formula, obviously. Minus 2 times B times C times the cosine of the angle I'm looking for, which is angle A, which is 72 degrees. Same deal as back in example 4, our first example of this video, that you can just go straight into square rooting both sides and then sub in this right-hand side or type in that right-hand side into your calculator in order to figure out what A actually equals. And when I do that and I round to 3 significant figures, I get that A is 307 meters. So that distance of the lake, or the length of the lake is 307 meters.